Hello and welcome to the next video with regards to straight lines. We're looking at the equation of a straight line in different forms. So the equation of a straight line can be written in a number of different forms. Y equals mx plus c is obviously the form which you see at GCSE. There's also two other ways of writing the equation of a straight line. I've got this one here, y minus y1 equals m x minus x1, and that regards any point on the line, so any coordinate that's given in the question we can use that in that form. And ax plus by plus c equals 0. Okay, so we can write it in a number of different forms. However, this form here, the second form, is what I will be using to find the equation of a straight line. I find it very useful and it's easy to rearrange from there. Anyway, before we get into actually finding the equation of a line, you've got to understand how to interpret equations given to you. Okay, and for you to do that, you need to know exactly what the base equation of a straight line looks like. Y equals mx plus c. Okay, so the m represents a gradient. Okay, a c represents the y-intercept, and the x and y are just coordinates that you put in. Okay, so if using that, if I look at the first equation, y equals 9x minus 4, if I make an equivalence, y equals 9x minus 4 and y equals mx plus c, it's very clear to see that the gradient is equal to 9 and the y-intercept is equal to minus 4. Not a massive problem there for part A. But what happens in part B? In part B, the equation looks different. It's not y anymore, it's 2y. But the problem is we need to get it into this form, y equals mx plus c, for us to be able to extract the relevant information. So what I need to do is divide through by 2. And when I divide through by 2, I will get this. So 2y equals 6x plus 8 is another way of saying y equals 3x plus 4. And that means the gradient is equal to 3 and the y-intercept is equal to 4. Okay, 4x plus 5y plus 10 equals 0. Now on inspection it can be quite difficult for students to understand what the gradient is and what the y-intercept is. Again, we need to get it into the form y equals mx plus c. Okay, so I need to rearrange that. So I'm going to make y the subject, or at the moment 5y. Okay, so when I make that into form y equals mx plus c, I've got 5y is there so far. Then I'm going to divide through by 5. And I get to that stage. Okay, so 4x plus 5y plus 10 is the same as that equation. And that means m is equal to minus 4/5 and c equals to minus 2. Okay, part D, y minus 3 equals 5x minus 2. So again, that's not in the form y equals mx plus c, which is a form which we can extract the gradient and intercept from. So I'm going to expand the brackets on the right hand side and then rearrange to get y equals mx plus c. And from that you can see that m is equal to 5 and c is equal to 7. Okay. The final one in question 1, you've got a fairly different looking equation, x over 4 plus y over 5 equals 1. What we can do, we don't really like these denominators 4 and 5, we can just multiply through by them. So I'm just going to divide through by 4 first of all. So multiply through by 4, and when I multiply through by 4 it affects everything else by multiplying that by 4. And then I'm going to multiply through by 5. Okay, I'm going to make y the subject, by dividing through by 4. Therefore my gradient is minus 5 over 4. And my c is equal to 5. Okay, so the main skill that you need to learn from this question, A to E, is if you ever asked to find the gradient intercept, or if you ever given the equation of a line in different forms, which is not y equals mx plus c, then you need to get it into that form in order to get the gradient and y-intercept. Right, next question. Find the equation of the straight line which passes through 1, 2 and is parallel to y equals 3x minus 5. Some students struggle with this type of question because they're trying to find an unknown equation. But let's think about this graphically, then we'll do the maths. So y equals 3x minus 5. That will cut through at minus 5 here, and it's got positive gradient, so it's going to carry on going. Okay, so this is y equals 3x minus 5. And what they're asking us to find is the equation of a line which passes through 1, 2 and is parallel to y equals 3x minus 5. So 1, 2, let's say, is there for the sake of argument, and we've got a line that we don't know what the equation is, but we know it's parallel to 3x minus 5. So for this unknown line, we know at least one thing. Well, we know one thing for sure, that the gradient must be the same as the gradient of 3x minus 5. So the gradient of this unknown line is 3. We also know that this unknown line passes through a coordinate, x equals 1, y equals 2. Once you know these 3 bits of information about any unknown line, you can find the equation of that straight line. I often call this the checklist. Do you have these 3 things? If you do, we can find the equation of the line. I'm going to use this form here. Okay. So this formula will help me to substitute numbers in and rearrange if needed and get me the equation of a straight line. So basically what I'm going to substitute are an x and a y value that the line passes through. So y minus y1, which in this case is 2, m is 1, sorry, m is 3, and x is 1. Okay, therefore 3x minus 3, and therefore y equals 3x minus 1. Okay, so the equation of this unknown line, which is parallel to 3x minus 5, is y equals 3x minus 1. Okay, and that's the answer. So let's just recap. Whenever you ask to find the equation of a straight line, you need 3 things, m, x and y. Once you have those 3 things, you can use this formula, which can help you get the equation of a straight line. Right, final one here. Find the equation of a straight line which passes through these 2 points. So remember, the equation of a straight line, we need 3 things. We need a gradient, an x value and a y value. Right, at the moment, I haven't got a gradient. X and y, I can actually use any of these coordinates for my x and y because the line, this unknown line, passes through both of them. I'm going to use 3, 4. So x is 3 and then y is 4. But the issue remains of the gradient. But however, we've already looked at the gradient from a previous video. We know how to find the gradient between 2 points. So we're going to use the formula y2 minus y1 over x2 minus x1. So remember, I'm going to label things x1, y1, x2, y2. Okay, so I've got y2 minus y1, y2 is minus 2, y1 is 4, so that's that. Then x2 is 1 and x1 is 3. let me just make sure I've got the right. Y2 minus y1, x2 minus x1. So I've got minus 6 over minus 2. Cancel, you get 3. So I've got a gradient of 3. I've got all three things that I need for the equation of a straight line. So I'm going to use my formula, y minus y1 equals mx minus x1. I'm going to substitute what I know. So I know my m is 3, I know my x is 3, I know my y is 4. Okay, so there's my answers. Okay, so the practice questions are all outlined here at the bottom of the page, and the stretch and challenge. I would recommend doing the practice questions, especially finding the equations of straight lines when you've got coordinates, or when you've got one coordinate and a parallel line. Okay, so questions 2 and 3 sort of on that similar skill set. You can also have questions that deal with perpendicular lines, and you have to do the negative reciprocal from the previous video. Okay, so in terms of what we've learned today, let's just recap. There are 3 different ways of presenting the equation of a straight line, one of which I would emphasize in terms of using as a formula, and the other 2 are different forms that you could be asked to get into. This form here, y equals mx plus c, is the best form to find the gradient and the y-intercept, which is what we went through in question 1. And the second form, as I said, I used once I've got an x value, a y value and a gradient. Yeah, that's the end of the video.